You know that that's given. Like I said yesterday, I put in those extra lines there for you so that way you see that it actually is a secondary step. It's another given. That B is the midpoint of MD. Well, back to the diagram. That tells me that MB and BD have to be the same. Well, we already marked MB with one tick mark, which means how many tick marks does BD have? One, because they're the same. Okay, so it's got to have one. So now I start looking at my next pieces. Well, AM is equal to MB. Well, that was the definition of the midpoint. That's how those two showed up. MB is equal to BD because, oh, that's right, another definition of midpoint. You had two midpoints given to you, which means you should have two definition of midpoints. Okay? It's kind of a little hint there. Any one of those givens that has a definition or a progression, those are going to be definitions of something, second bisector, bisector, those lines. Now go back and look at your diagram. It's telling you something about segment MD. So if I look at my diagram, MD, okay? That segment is made up of two smaller segments. It means you are doing what? There you go. Segment addition. Okay? The next step, what changed between C and D? What changed there? They both wind up with the MB. The BD changed to an MB. Why? Substitution. A lot of times when something just changes, substitution. Okay. And then why do we rewrite it as multiplication? Here we go. I had students yesterday that were just looking at the given statements and stuff, and they were just kind of going through and realizing, oh, I know when I see something going from addition to multiplication, it's just definition of multiplication, to write it down right away. They recognized it, they just wrote it down. They saw something in one of the problems where we were switching from congruency to equality. They wrote congruency, definition of congruency. They did that right off the bat before following through the whole proof. Their eyes caught something, and they just rewrote it. Okay, that's something you can do. There's nothing wrong with it. The second proof, though, on the other hand, did have something a little bit weird. Okay? Now, make sure you have a progression sheet up, because I want you guys to make sure you have this on there. You already do have something similar to it on there, but I want to reiterate the information. So let's see. Right? Change my line style. All right. So starting off with this one, you're given that segment AL is equal to SK. Automatically go to your diagram. Mark it. Nothing you can do about it. Okay? No progressions, no definition. It's just marked up in the diagram. This next statement is different. LS is congruent to or equal to LS. Right, it's reflexive, very good. Anytime you are equal to yourself, it's called the reflexive property. Now, on your progression sheet, we had something on here that said, look for the shared side. I think we drew a triangle with an altitude drawn through it. That side was equal to itself because of reflexive property. So maybe in that thing, you would write down, anytime you see something equal to itself, it's always reflexive. Okay? You are equal to yourself, it's reflexive. The reason why they have to do this, because when you look at the diagram, if I say LS is equal to itself, I can do that. It's equal to itself. So, excuse me, if I have two markers that are equal to each other. And I add to those markers the same value, same amount. Bless you. Don't those two markers still have to be equal to each other? So if I add to those markers two other markers that happen to be the same size, thanks, Captain. They're still equal, aren't they? Whenever I add the same amount to something, it stays equal. If I add the same amount to both sides of the equal sign. See what they did here? They added the same thing to both sides of an equal sign. When you add the same thing to both sides of the equal sign, what are you doing? Add prop equal. Think of it this way. If you want to think of this in terms of numbers, let's say this is 4, which makes this a 4, and this is a 7. So does 4 equal 4? Yeah. Does 7 equal 7? Does 4 plus 7 equal 4 plus 7? Yeah. I mean, I can say thing with both sides. The only thing that's different is I'm just using letters. I'm using letters to represent very simple addition problems. Okay? Everybody with me on that so far? Okay. Now, if I'm looking at it then, AL plus LS equals AS. Well, AL plus LS equals AS. Ooh, two smaller segments added to equal a larger. What is that called? You may not have to know anything about what's going on, but if you look at the diagrams and go back and forth, you should be able to tell that you have segment addition going on. That's something very simple to identify. Okay, go back again. SK plus LS is LK. Wait a second. SK plus LS, let's go this way. Ooh, two smaller segments added to equal a larger. What's that one? Segment addition again, isn't it? You're adding two segments to make a different one. AS and LK. What do you think? Look back and forth. Where do you have things written down? Think about numbers. What's 4 plus 7? 11. What's 4 plus 7? 11. Okay. Now, 4 plus 7 equals 4 plus 7, doesn't it? That means 11 has to equal 11. Not reflexive here. Do I have somewhere stated that AL plus LS equals SK plus LS? Which means two things that are equal other things, the other things are equal. Substitution. Guys, just look up and down here. These two are here and here. That means these two guys have to be equal. Substitution. Okay, where you get substitution from. Putting in something for something else. When things get rewritten, a good guess is substitution. Seriously. A good guess. You don't know what's going on. If something just has been rewritten, it's probably substitution. It's a good strategy to remember. Let's see. On the other side, whole bunch of angles. Whole bunch of angles. In this one, you didn't have any progressions. You just had some statements. You just had a couple of statements. There was a look for on our progression sheet that allows you to do something here. Hopefully you caught it. So as you start, you know you're given 2 and 3 are congruent. So mark the diagram. 2 and 3 are congruent. That's given. Okay. So why can I say 3 and 4 are congruent? What are those called? Vertical angles. On your progression sheet, you have the thing that says look for vertical angles. And you have a diagram of what it looks like. That looks a lot like it. Vertical angles. We know that if you can see that you have vertical angles, you can say vertical angles are congruent. That was our reason. Vertical angles are congruent. So that's your reason. On your progression sheet, you should have a picture of what vertical angles look like, because that's something you can imply from a diagram. If you don't have a picture of vertical angles on your progression sheet, make sure you put one on there. And make sure you put state angles are congruent to each other. Reason, vertical angles congruent. Okay? So now I go back here and I can mark it. Okay? So 2 is congruent to 3, 3 is congruent to 4, which means 2 is congruent to 4 because of 2 and 4 are not vertical angles. Substitution, or there's another one you could use. I'll let you guys go with substitution here, but technically, remember we did this? A equals B, B equals C, A equals C. See how see how the numbers are 2 equals 3, 3 equals 4, 2 equals 4? See how these guys are on that diagonal? A lot of syllogism, but we call it the transitive property. That's on your property list. The transitive property is on your property sheet. Okay? Anytime you see something on a diagonal like this, we say it's transitive. Not technically substitution. It's transitive. Anytime you have this diagonal, might not be a bad idea to put it in. So what I've done in the past for students for progression on this, I usually have them make a little note, like, is it transitive property or is it substitution? How do you tell which is which? Is it transitive property or a substitution? Well, let's see. Transitive property is this. A equals B, B equals C, A equals C. This means it's transitive. When it is not on a diagonal, it's substitution. That's how you tell the difference between the two. Transitive property is more specific than substitution. If it's written out, 2 is congruent to 3, 3 is congruent to 4, where it's repeated like that, then it means it's going to be transitive property. If it is not, bless you. If it says, A equals B, C equals B, A equals C, that's substitution. That's the difference between the two. That's going to be the difference. So if you do wind up coming across something like that where you recognize that things have been repeated, it's not a bad idea to double check whether or not you're using transitive or you have to use substitution. And this is what it does. That's the difference between the two. Okay? Does that make sense? So here, we're not going to use substitution. We're going to use transitive because of the diagonal. Okay. Excuse me. So back to this one. So we went 2 is to 3, 3 is to 4 because of vertical, 2 is to 4 because of transitive. Now back to the diagram then, why is 1 congruent to 2? Vertical angles again. 1 and 2 are congruent to each other because these guys are also vertical angles, so we write vertical angles are congruent. And then lastly, 1 and 4. Why are 1 and 4? Which one will that be? Substitution, very good. 1 and 4 would have to be congruent because of substitution. There is no diagonal repetitiveness there. Okay? Okay? And that's how that works. So this one, there's no progression. But you had to identify that you had the vertical angles. And the reason when you say vertical angles, you can't just say vertical angles. You have to say that vertical angles are congruent to make that work. So hopefully you've got a congruent symbol on your progression sheet. If not, make sure you do. Because if that comes up, you don't have it, wrong. Then the last one you guys did last night was a bunch of complementary things. Now we did, I think we started one similar to this yesterday, but I don't think it has many angles to it. So let's see here. 1 and 2 are complementary. What's my reason? Given. That's given. According to your progression sheet, what do you do after you say that you have complementary? Definition of complementary, but what are you stating here? We're stating that 1 and 2 are equal 90. Okay, that was it. So once you have complementary, you say the angles add up to 190, or add up to 90 is the definition complementary. Why are angles 1 and 3 congruent and 2 and 4 congruent? Those are given. So those are given. What changed between steps 3 and 4? Perfect. Definition of congruency. It just went from congruent to equal. Okay. So why can you rewrite it as 3 plus 2 equals 90? Does it say 3 and 2 are complementary anywhere in there? Nope, then you can't say that. Substitution. 1 and 3 are the same, which means anywhere I have a 1, I can replace it with a 3. And why did I change the 2 to a 4? Because it's substitution. And I know we mentioned this, but I don't know if we wrote it out. When you are doing definitions, if we know that angles, if we're given that 1 and 2 are complementary, that means they add up to equal 90. On the other hand, if you say 2 angles add up to equal 90, you can say that they are complementary. The definitions work going in both directions. So this last one would be definition of complementary. Because since 3 and 4 add up to 90, they have to be complementary. Those definitions work going both directions. It's called a biconditional statement. It works going both ways. I think we'll do biconditional statement one day. Before we get into classifying triangles and jumping. Not terrible? Hope not. This is the complexity that we're working through. Okay. Yes, sir. Yes, sir. Still have it. We got 4 of them. Fill in the blank. I know I did not make the copy on this one, so take a second, write it out, draw the picture. Let's go through it. So what I want to do right away, this is what I always do, I mark up my diagrams. Okay? So as we mark them up, let's see if this works. Hopefully you're not sleeping anymore. Come on, man. Sit up. You got it. Anyway, so when you get into this, mark it. Those two angles are the same. Because it's given. Before you go any further, before you write anything down, look at what they're trying to get you to prove. They're trying to get you to prove that the two smaller angles on the outer edges, those two are the same. I'm just putting a little X there. They're trying to show you that those two are the same. You want to prove that those two are the same. So before you get going, do you have two angles that are the same angle to start with? The two larger angles, because that's given to you. Those larger angles are made up of how many smaller angles? Two of them, right? Which means you could use something about angle addition maybe to say that. Which means those two smaller angles have to equal each other. And don't they have an overlap in the middle? What would you do to get rid of an overlap? How do you back something out? What math property takes something away, guys? Come on. Come on, guys. Okay. Before you do any math, angle addition, anything like that, what do you have to change? Symbol. You got to change it out of the computer. So at this point, if you have no clue what you're doing, you have no idea what to do, you can always go to the diagram and make something up. Look at what you have. You have angle AEC. What is that angle made up of? It's made up of two smaller angles. So if you have no clue what you're doing, just by looking at the diagram, you get half a chance, don't you? You should never say, I don't know what to do. You should never say, I don't get it. You should look at a picture, infer from some information. That angle is made up of two smaller angles. Made up of angle AEB and angle BEC. Why can I say that? Are those segments? Angle addition. Okay. So if I do that for one of them, can't I do that for the other? And do that again. I know that by looking at my diagram, angle DEB is made up of two angles. It's made up of angle BEC and angle CED. Same reason. Hey, aren't those two big angles equal to each other? Yeah, we already wrote that down, didn't we? That means those two smaller angles that make up the big angles have to be what to each other? They have to be equal. We're doing the same thing. So we write it out. And what's my reason? Leave something in for something else, guys. What do they have that's the same on both sides? How do you get rid of it? How do you get rid of it? Wanted us to prove AEB and DEC. Is angle DEC the same as CED? They're the same, aren't they? It's just going in different letters, are going in different directions. Do I have to change it, or is it okay? You don't have to. You don't have to change it. There's no reason to. So, what's the last thing I have to do now? Change the symbol. Yeah, change the symbol. Students always ask, what do I do to prepare for proof quizzes or tests or anything like that? And I always tell them the exact same thing. Rewrite your progression sheet. That way you know where everything is. Secondly, we have done, I think up to this point, 20 or so, at least 20 or so proofs, I'd say. And whether they're on a worksheet or in notes, I always tell students, say, hey, while you're going through it, if you're trying to remember how to do something, how do you set it up? You quite literally take a piece of paper, cover the proof as you go, and write down what you think you should do. Oops. Yeah, don't do that. Write down what you think you should do. Because you're all rewriting what I do, means you should all have every single right answer. That is how you prepare on these things. You reference your charts back and forth, all the while just rewrite it. It helps you understand where things were going. It helps you remind you where things are on your pieces of paper, and it helps you figure out how did the flow of the problem go. Well, in this case, we went congruent, equal, adding. Well, why did I go congruent, equal, adding? Then you go back and look at your diagram. Okay, why did I do this? Oh, that's right, because if I look at what starts with, you have the two larger angles. Those two larger angles share something in the middle. I got to get rid of the middle. The only way we know how to get rid of the middle with angles and stuff is we have to say that they're adding together at some point. We have to say that they're equal to each other, and then we have to back them out. This works the exact same way with the segment. In fact, we have done this exact same proof, but in segment form. Same thing. Add them together, subtract out the middle. And this is kind of how this stuff works. Let's see, I think I got one more like this one right now. This one more, we start with the algebra, we end with congruency. Start with algebra, end with congruency. See how we do on this one. Then what I'll do tonight let's see here. So using information, we have twice the measure of angle ABC equals the angle AD. Okay. Prove ABC is congruent to CB. What does twice the measure of angle ABC mean? You're adding it together twice, right? put in a hard bearing, and you can do that. Now, if I'm looking at it, what is angle ABD? A small angle or a big angle? It's a big angle, isn't it? What is that big angle made up of? Before I'm not writing anything down, just look at my pictures. What is it made up of? The two smaller ones, right? Two smaller ones. So if you have a big angle made up of two smaller ones, what would you use to write that out? Addition of what? Where you at? Angle. So you can write something about angle addition because you're just, and all we're doing right now, we're just kind of rolling through the ideas of what can we say. We're just kind of picking up on some clues here. All right. So let's start with the given. We know that if I take double angle ABC, it equals angle ABD. Well, very nice of them to give us something to do. Thank you. What could you do with that doubling ABC as your next step? What would you say? Take a guess. What's that? What do you mean by write it out? Perfect. Only thing you know how to do when you have numbers out in front, split it into addition problem. It's the only thing you know how to do. You don't know how to do anything else. Okay. 2 minutes ago, you guys also told me that angle ABD is made up of two smaller angles, isn't it? What are the two smaller angles that make up angle ABD? Okay. So we know that angle ABC plus angle CBD make up angle ABD. All I'm doing here is I'm looking at my diagram. I know that this one plus this one equals the whole thing. What did we do? Angles. You're adding two angles together to equal the larger. Take a guess of what you're going to write next. Right, we're going to use substitution, but what are we going to write out on the statement part? Louder, louder, louder. Perfect. Again, we know that we have two things that are equal to the same thing, correct? That means those two things have to be equal to each other. Because of good old-fashioned substitution. Boy, oh boy. Look what we have now. Huh. Looks a lot like the same thing we've been doing over and over and over and over again, isn't it? Do we have the same thing on both sides and both sides? What do we do to get rid of it? Yep. Which therefore gives us ABC equal what? What's left? There you go. You're going to see excellent. Change the sign. Proofs are a way for you to organize thought. Valid argument. Go through a specific list of objects in a specific order. Can you follow directions? That's what a proof is. It's not jumping to the end of the Lego when you're trying to build all your Legos. You have to start at the beginning on the interior of it before you get to the wings of the airplane. Otherwise, That's the idea behind these things. It's a matter of keeping your stuff with you, not losing it. I don't know how many of you guys have been doing this, but don't forget, take a picture of your progression sheet, because God forbid you accidentally lose it. Then you can still come in and get another one and rewrite it. Okay? It's kind of a thing. What I was going to have you guys do this evening. Remember a couple days ago, we had that 2-page staple packet thing. There were a couple of proofs on here that we haven't done yet. This one is on the bottom of the 3rd page. And this one's on the top of the 4th page. We haven't done those two. But also, I want you guys to walk through these if-then statements. That way you can get the idea of what properties are being used by looking at something. For example, if I have angle 1 equals angle 2 and angle 1 equals angle 3, what could you say? Angle 1 equals angle 2, angle 1 equals angle 3. What can you say? Boundaries. And why would you say that? What property are you using? Perfect. That's exactly what you're doing. Okay? Very, very right. What you say is what these are just kind of an idea of what could you write if you're given this information. Angle 1 equals angle 2, angle 1 equals angle 3. Therefore, angle 2 equals angle 3 because substitution. AL bisects angle AF or FAB. AL bisects angle. What's up? What would that look like? What would that look like? What would you draw first? Okay. Well, this is a ray. There's only one arrow, so I would draw angle FAB. Where does that ray have to go through? Where does that ray start? At A. If it bisects it, what does it do to the angle? Splits it in half, splits it into 2 equal parts. So this is an L then, right? These two have to be the same. So if given a bisector, your progression sheet says to state the angles that are congruent. Well, what are the 2 angles that are congruent? Very good. And the reason? What's that? That's only for switching signs. What does your progression sheet say to do? You should never get this wrong. It's always on the sheet. Every answer is on there. What kind of a bisector? Correct. Reason, definition, angle bisector. I'm glad you said that mistake there for a second about bisector. Ladies and gentlemen, if you have a bisector, you have to say what type. Is it an angle bisector or is it a segment bisector? You have to say what it is, otherwise it's wrong. Okay? So do those if-then statements and those 2 proofs. What I'll do later on today is I will post on the calendar the PDF file of the answers so you guys can check. Okay? And we've got even more stuff to prepare for. But I'll have that up I'll probably have that up around lunchtime. It won't be a big deal. Okay? Sound good? Yes. I don't remember. I honestly don't remember. There's 4 proofs, but each there's 3 of them that are fill in the blank, and 1 of them is on your own. Okay? So They're not any more difficult, any easier, or anything. Like they're all on the same complexity of everything we've done. You know, 5, 6, 7 steps with a lot of substitutions, some congruency switches, angle addition, second addition, midpoints, bisectors. It's all that kind of stuff. Nothing on there that shouldn't be that. All right, excuse me, rephrase that. Everything that's on it should be on your progression sheet. That's why I always say it's always a really, 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 really smart idea to revisit your progression sheet, to rewrite it. If you need to, there are spares, blank ones in the back in the black bin. Help yourself. Please grab one if you want. But yeah, we've done about 20 some odd proofs, so you've got a ton of things laying around, guys.